Number 21, yet another interval convergence problem with the additional 17th derivative question. So to find the interval of convergence of this power series here, we go through the motions. Ratio test first to get the radius of convergence. I set it up here, limit as n goes to infinity. A sub n plus 1 divided by a sub n. I'm going to go a little faster here, so definitely pause the video if you want to check out the work that I did. Okay, but hopefully if you're following along in this series, you're getting the hang of these. So I'm going to jump some steps, okay? We start simplifying, you should get x minus 2 out in front. It doesn't depend on n, so it's a constant, but keep the absolute value, and then you start simplifying. So when we have a rational function like this, remember the technique is we really only care about the biggest degree on the top and the bottom. So if you expand everything out, it'll be n to the fifth on top, similar for the bottom, okay? The degrees are the same, take the ratio to leading coefficients. That's 1, so the limit is 1, but then we still have this x minus 2 out in front. Okay, so we set that less than 1 for the ratio test. We start solving the inequality, so minus 1 is less than x minus 2, less than 1, and x is between 1 and 3. Okay, we got to check our endpoints. So we plug in x equals 1 into the original series. We would get minus 1 to the n over there, and then this is n plus 1 squared over n cubed. So does this converge or does this diverge? Well, it's a alternating series. So we can use the alternating series test. I took the limit as n goes to infinity of this guy without the changing sign at 0, and then I took the derivative of that guy and showed that it's negative for n is greater than or equal to 1. That means it's a decreasing sequence. I didn't write that, but that's what this derivative was for. Okay, so the series converges by the alternating series test. Again, you can go check out the math that I did here by pausing the video if you need to. All right, and then we check our other endpoint, n is equal to, sorry, x is equal to 3. Okay. This is what we would get if we expanded it out. This, again, looks like a rational function. What's the technique to determine if these are convergent or not? We like to use the limit comparison test. We compare with the biggest degree on top and the biggest degree on bottom, so n squared over n cubed, which is 1 over n, it simplifies to. We know this is a p series that diverges with the harmonic series. So we do the limit comparison test. It's 1, it's finite, and it's positive. Yeah, it's finite, and it's greater than 0. I should say, not positive, greater than 0. So because 1 over n diverges, this guy diverges as well by the limit comparison test. Therefore, the interval convergence is -1, less than or equal to x, less than or equal, sorry, less than 3. We don't include 3 because we just checked that it diverges. Okay, so that's first part of the question. Now we're asked to evaluate the 17th derivative at 2. So what's the technique for this? If you follow along in the series, as I've explained before, the way to do with this is we need the 17th degree term. That's when n is 17. Okay? We would take the coefficient that's already existing when n is 17, and then we multiply by 17 factorial. That 17 factorial comes from doing the power rule 17 times. Okay? And remember, 2 is the center of the power series, so this is why everything works nicely. Okay, so I believe that's on the next page. Oh, I guess I didn't solve for that, but it'll be 17 factorial times 18 squared over 17 cubed. Okay, because n is 17, so you just plug into that. Okay, that should be the answer for this. I thought I solved this, but anyway, that's the technique to solve that. Pretty straightforward once you get the concept down of it's at the center, so all higher order terms would cancel out, and any lower order terms, because you took the derivative 17 times, they all went to 0 already. So the only term that really matters is the 17th degree term when n is 17. You'll have that coefficient out in front still, and then you have 17 factorial from doing the power rule 17 times. Okay, that's it for this question. Pretty standard, typical question, again, in my opinion, so you should know how to do this. And hopefully, if you've been following along this series sequentially, then you got the hang of this by now. So this is why practice makes perfect. All right. Please give this video a like if this has helped you, and hopefully see you in another video as well. Bye.